Hi everyone, welcome to week 6. This week we're going to start chapter 6, which is working with rational expressions. The motivation for rational expression is rational numbers. Numbers of the form p over q, where p and q are integers. For example, 22 over 7, 11 over 3, 3 over 7, etc. Taking a motivation from this, we can define a rational expression as being of the form px over qx, where p and q are polynomials, which are basically which means many terms. So, for example, you have this bunch of examples here. As you can see, the numerator is a polynomial, px, and the denominator is also a polynomial. Now, we can write a rational expression in the form of a rational function. For example, f of x equals 120x over 100 minus x. This means that we can evaluate them at various points, which you have already learned how to do. F of 10 would give you 40 over 3, f of 0 is 0, f of 80 is 480. F of 100, when you try to find, leads to a problem, which is a division by 0. We've already encountered this problem before, and we know how to deal with it. We deal with it by removing it from the domain. So our domain is r minus 100, or everything from negative infinity up to 100, remove 100, and then 100 to infinity. And we write this using the union symbol. In general, if you have a rational expression of the form px over qx, or a rational function, to find the domain, we have to remove all values of x which make the denominator 0. Now, if you want the denominator to be 0, we're going to see that when things are expressed as sums and differences, and they're equal to 0, they can have many possible solutions, like 7, negative 7, 3, negative 3. But if the product of two things is 0, then one of them has to be 0. And that's why factoring is so useful. Because from 2x squared minus x minus 1 equals 0, I end up with 2x plus 1 times x minus 1 equals 0. And then, if, say for example, I end up with squiggle times triangle equals 0, then either squiggle is 0 or triangle is 0. We can only get the product to be 0 if one of the numbers is 0. So either 2x plus 1 is 0, which gives you x is negative half, or x minus 1 is 0, which gives you x is 1. So the domain is all real numbers with negative 1 half and 1 removed. Or you go all the way from negative infinity to negative 1 half, remove negative 1 half, you go from negative 1 half to 1, remove 1, and then you go from 1 to infinity. That's it for the first video.